We're on problem 107. 107. Any decimal that has only a finite number of non-zero digits is a terminating decimal. For example, 24, the examples they give us 24, 0.82, and 5.096. So they're saying if you just have a finite number of these non-zero things, at some point you have to end and have zeros just left over. So that's what they mean by a terminating decimal. If r and s are positive integers, so r and s are positive integers, so positive integers, and the ratio r divided by s is expressed as a decimal. So r divided by s, so that is expressed as a decimal. Is r divided by s a terminating decimal? R divided by s terminating. So essentially, it wouldn't work if r and s, if this is 1/3. That's not going to work because you're going to have 0.3 forever. So they're saying, does it at some point end? This is interesting. So statement 1 tells us that 90 is less than r, which is less than 100. That statement by itself doesn't help me. Now let's say that r was, I don't know. Let's say that r was, let me think of a good r. So 90. Let's say r was 93. If r is equal to 93, and then s is equal to, well, let's just say that s, for the sake of argument, is 3 times r, right? Actually, I don't have to pick an r. Whatever r is, I can just pick an s to be 3 times r, right? And I'm not going to get a terminating decimal. On the other hand, if I pick s to be 2 times r, then I'm going to have a terminating decimal. So statement 1 by itself isn't going to help me, right? Statement number 2. I hope you understand that I can pick any s to make it terminating or not at this point, no matter whether r is constrained to between 90 and 100. Statement 2 tells us that s is equal to 4b. S is equal to 4b. Now this is interesting to me. So where did this b come from all of a sudden? Any decimal that has only a finite number of non-zero digits is a terminating decimal. For example, okay, if r and s are integers and the ratio s is equal to 4b, where did this come from? Let me look up. What is? I think this is a typo. Because where did b come from all of a sudden? Oh, yeah, when I look at the solution, they say s is equal to 4. So that's definitely a typo. 4b. S is equal to 4. Okay, that makes a lot more sense. All right, so if s is equal to 4, pretty much any number, when you divide any number by 4, you're going to have a terminating decimal. It's either going to be divisible by 4, or it's going to be the worst case, if you have 1 divided by 4, that equals 0.25. So no matter what, when you divide something by 4, you're always going to have a terminating decimal. It's never going to repeat forever. I mean, you can try it out with every no matter which of these, no matter what number you divide, if you view it as a fraction or kind of your 4th grade remainder problems, the remainder is either going to be 1, 2, or 3. If the remainder is 1, the decimal is going to be 0.25. If the remainder is 2, the decimal is going to be 0.5. And if the remainder is 3, the decimal is going to be 0.75. In any case, as long as s equals 4, you have a terminating decimal. So statement 2 alone is sufficient, and statement 1 really doesn't tell us much. And I'm annoyed that they had that b typo there. Next problem. 108. Okay, they've drawn a triangle. Right there. Let me see if I can draw it properly. Okay, and then it looks like a. All right, there you go. And let me label it. So this is B, that's A, that's C, this is Y degrees, and this is D, and this is X degrees. In the figure above, what is the value of x plus y? So x degrees plus y degrees. So x plus y is equal to what? All right, question number 1. So they don't tell us anything else. They don't tell us this is an equilateral triangle. They don't tell us that these angles are equal. They don't tell us it's symmetric. They don't tell us anything about this triangle so far. So statement number 1 tells us that x is equal to 70. Well, just by x equaling 70, that still doesn't help me. I still don't know what y can be. I mean, you could draw this interior triangle in a bunch of different ways, and you can see that the angle could change depending on how much you lift up d or compress d. This y angle can change irrespective of what x is. So x is equal to 70 does not in any way give me any information on what y is. Statement 2. Statement 2. Triangle ABC and triangle ADC are both isosceles. Isosceles. So isosceles means that these two sides, well, actually it doesn't mean necessarily that those two sides are the same. I mean that's kind of tends to be someone's immediate assumption when you say isosceles. Oh, maybe that side is equal to that side, but no, it just means that two of the sides are the same. So likewise on this triangle, although you can at least here, can I make an argument? No, you can't make an argument which two sides are going to be the same. So even if you assumed that both of those sides are the same, you're still not going to, because you don't know, my gut instinct would say, oh, that side's the same as that side. But no, I can't make that assumption, because it could be that this side is equal to this side. That would still make it isosceles, and this side is kind of viewed as like the base side. And it's a very big difference, because if these are the two equal sides, then if this is x, this is going to be x. But then if I take the other scenario where if these are two sides, and if this is x, then both of these are going to be 180 minus x divided by 2, right? Because this would be, the bottom line is this still doesn't get me anywhere, even if I know that this is 70 degrees. So I'm going to go with E. Not enough information to solve this problem. 109. 109. Are positive integers p and q both greater than n? So p, q greater than n, and they're positive integers. They already told us that, positive integers. Okay. They say p minus q is greater than n. P minus q is greater than n. Well, I'll give you a case right now where that doesn't satisfy this. What if p is equal to 10, q is equal to 1, then we, and n is equal to 2, right? Then 10 minus 1 is 9, is definitely greater than 2. But look, q is not greater than 2. 1 is not greater than 2, so q wouldn't be greater than n. Or I could say, it could be, 110 and 108 would equal, and when you subtract, you get 2. And in this case, q is bigger than 2. So this doesn't give me enough information. I can think of two combinations of PQs and N's. One that says that Q is not greater than N, and one that says that Q is greater than N. So one by itself isn't enough. Statement 2. Statement 2. Q is greater than P. Q is greater than P. Well, that still doesn't help me. And even if I used, both of these statements actually cannot be true simultaneously, because if these are both positive integers, which they told us, right? If they're both positive integers, well, greater than n, both greater than n. They didn't tell us necessarily that n is positive. So n doesn't have to be positive. My logic for statement 1 still holds, but let's see. If q is greater than p, if q is greater than p, if this by itself doesn't help me much, because I can think of a similar combination to this, right? I could say q, q is equal to 10, p is equal to 9, and I could make n is equal to 2, or I could say n is equal to 15, right? This in no way constrains what n is, so it by itself doesn't solve it. But what if we were to use both constraints? This is the interesting case. What if we were to say that p minus q is greater than n, and q is greater than p? So, we know that both p and q are positive. They told us that in the problem statement. If p and q are both positive, and p and Q is greater than P, this is going to end up becoming a negative number, right? These are both positive, and this is the larger of the two positive numbers based on the second constraint. So this is going to be a negative number. And so if a negative number is greater than n, then we can be sure, we can be positive that both P and Q are greater than n, because they told us that P and Q are positive. So actually both of these statements imply that n is negative, because we have a negative number here being greater than n. And if n is negative, then both P and Q are definitely greater than n. So both statements combined are sufficient to answer this question. And the answer is actually true. I'll see you in the next video.